Hello, everyone, and welcome to Jack's Math Notebook. This is our ninth video in a series of videos related to how to find the solution to a system of two equations. We have been using substitution method lately, and today is no exception. Because of practice, the substitution method is a pretty good technique to use when finding a given solution to a system of two equations. And let's take a look at big example 3 and see how the substitution method applies here. And in this case, we have 5x minus 3y is equal to a negative 11, along with x minus 2y is equal to 2. All right, and some of you have already gotten frustrated because you do not see an isolated variable. I have bad news for you, my friend. We're going to have to isolate that variable ourselves, but the good news is that we could pick an easy equation to do that with. And I say we use x minus 2y is equal to 2. And let's write it over here in which we have x minus 2y is equal to 2. And all we have to do is just add a 2y to both sides to isolate x. And so now we see that x is equal to 2y plus 2. And that's good news because see now right here in 5x minus 3y is equal to a negative 11. We're just going to replace that x with 2y plus 2. And so now that we have the expression written right here, we're just going to distribute this 5 across the parentheses. And so now we have 5 times 2y, which will give us 10y, 5 times 2, which will give us 10. And so now we have 10y plus 10 minus 3y will equal to a negative 11. And so right here, let us combine the like terms. So we have a 10y and a negative 3y. 10y minus 3y will give us 7y. So we have 7y plus 10 is equal to a negative 11. And in order to get variables on one side and numbers on the other side, we're going to have to subtract 10 from both sides. And now guess what? We have 7y is equal to a negative 21. And that begs a question, what number times 7 will give us a negative 21? All right. So I understand that you may not have that answer right here now because you're doing a lot of algebra and your mind is kind of like catching up to things. But if that happens, just divide both sides by 7, and you will find that y is equal to a negative 3. Yay, we got one of the variables out of the way. And all we're going to do is wherever we see a y, we're going to replace it with a 3. And let's do that with the easiest equation again. Yep, we're picking on this one because it's easy. All right, so we're just going to say that x minus 2 times a negative 3, well, that's going to give us 2. And you probably say, well, why did I put a negative 3 here? Because I'm replacing this y with that, you see? And so a negative 2 times a negative 3, well, that will give us a positive 6. And so now we have x plus 6 will give us 2. Okay, to find out what x is, we're just going to subtract both sides by negative 6. We're going to subtract both sides by 6, rather. Let me repeat that. In order to find out what x is, we're going to subtract 6 from both sides. Yes, that's what I meant to say. And when we do that, we discover that x is equal to a negative 4, and we have our solution. The solution is at negative 4, comma, negative 3. That's where these two equations meet. And let's move on to big example 4, in which we have 2x minus y is equal to 16, and negative x plus 2y is equal to a negative 8. And so let's pick on this top one because it looks like it's going to be the easier one to work with. And so now we have, and so what we could do right here to get y all by itself, let us subtract 2x from both sides. And now we have a negative y is equal to a negative 2x plus 16. All right, so this looks like right here, but your algebra teacher doesn't like this awkward look. They don't like that a negative sign next to a variable like that. So he or she might ask you to divide both sides of this equation by a negative 1 to kind of straighten it out. And so now when we do that, we will get y is equal to 2x minus 16. Believe it or not, this right here is the same as that. And so we may as well go with something that's a little easier to work with. And guess what? Y is right there. We could replace that y with 2x minus 16. You see how that works? But what we're going to do, we're just going to plug it back in here. And so we're just going to say 2x plus 2x minus 16 is equal to 16. Combining the like terms, we have 4x minus 16 is equal to 16. Balance that equation by getting variables on one side and numbers on the other side by adding 16 to both sides. And when we do that, we have 4x is equal to 32. And the question is, what number times 4 will give me 32? In case you've been doing too much algebra, the answer is 8, or you could just divide by 4. And you know that 32 divided by 4 would give us 8. And so now we have x is equal to 8. And so now we're in good shape. And so now our next adventure right here is to use that 8 to help us find y. And so let's go back to our top equation because it seems to be the easiest one to work with. And so let us plug in that 8 wherever we see an x. And so now we have 2 times 8 minus y will give us 16. 2 times 8 is 16. 16 minus y will give us 16. All right, so all we have to do is just subtract both sides by 16 because we want to get the variable on one side of the equation. And so now we have a negative y is equal to 0. Sorry with these negative variables, but all we're going to do is just divide both sides by a -1 to clean that up. And so now we know that y is equal to 0. And when we plug it in, everything checks out. And so the solution, these two equations will meet at 8, 0. Yes, you have been given a lot of algebra. And I understand you can always pause the video and give it the once over or replay this video as many times you need to gain a deeper understanding of the substitution method as it relates to getting the solution to a system of two equations. But in the meantime, you can always comment, share, like, and then subscribe to Jack's Math Notebook for more content. Thank you and goodbye.